In this video, we're going to learn how to work integration by the method of parts. Now, what is integration by parts? So first of all, let us look at a function f of x, and that is equal to y. So let's say that function is u multiplied by v. So let's say u is a mini function. I could call it f1, a mini function in terms of x, and v also should be another one in terms of x. So this will be f2 in terms of x. So you just need to know that u and v are functions in terms of x. So if you wanted to differentiate this, that will be basically written as f prime of x, and that will be the same thing as dy dx. And basically we need to use the product rule for differentiating this. So that should be v du plus you will have u dv over there. Now, we already know that y is the same thing as uv. So we could also change this and rewrite it this other way. So this could be rewritten as d of u multiplied by v dx, and that is the same thing as v du plus u dv. So it's pretty much the same thing. Now, if we wanted to change this back, or I should rather say this one, if we wanted to take this back to the original form of y, then we would need to use antiderivative, which is integration. So we need to integrate it. Now, if we wanted to do that, that will be integral f prime of x, and that will be integral d of dx into u multiplied by v, and we need to integrate this whole part. So we would integrate this one and come over to this and integrate that also. So that is going to be integral u dv. Well, that should be v du plus integral u dv over here. So we know this is basically going to change that function and take it to the original form that it had in the beginning. So this is what you're going to have. You're going to have f of x, and this is going to be uv, or u multiplied by v. And this is going to be integral v du, and that will be plus integral u dv. So as it is, what we have here now is a form that will take us very close to the formula of the integration by parts. And as a matter of fact, we're going to use this to form that formula. So let us say I want to make integral u dv as a subject. So that is going to be uv minus integral v du. And so this is the basic formula of integration by parts. And so we need to use it in order to solve some questions, some of the questions which we'll deal with in this video. Okay. So let us try out the first question. Say you were given integral x sine x dx. So what is going to be the integral of this? Now we need to take this expression and make it or compare it with this form. So in this case, we're going to choose x to be u. So let u be equal to x. Now we need to differentiate this because it's in its original or normal form. Now we need to differentiate that with respect to x. So that will be du dx, and this will basically be 1. Now I want to make du as a subject, so there will be no dx there. So that basically should be 1 dx. So that is what I have there. And then I will take the whole of sine x dx and make it to be dv. So let dv be equal to sine x dx. Now, since we already have this in its differentiated form, I will basically take it back to the original form. So that is going to be by the method of integration. So that should be integral dv, that will be equal to integral sine x dx. So of course, this is going to take this back to v, and we need to find the integral of sine x, which is a negative cosine x. So that is what we have. Now we're going to use these forms and plug them back into the equation for integration by parts. So we need to take note of this and this one. And we would also need to use this. So yeah, now we have u to be x. And then v is negative cosine x. So I'm going to write that there. Then we have minus integral v. We already know v to be negative cosine x. And that will be multiplied by du. In this case, we have du to be 1 dx. So that is going to be 1 dx. Now we know that this is the same thing as negative 1. So I could actually take negative 1 to the outer form of this expression. So that will basically be negative multiplied by negative 1. And so that basically should give us a positive. And if we multiply negative cosine x by x, that should give us negative x cosine x. So this is going to be negative x. And we have cosine x there. And here we're going to have plus integral cosine x dx. I think I can clear this one out now. So finally, we need to find the integral of cosine x. That is going to give us sine x. So this is minus x cosine x plus sine x. And that should be plus c. So that is going to be the answer to this question. The integral of this is the answer to it. Now let us try out some more questions. So what if you were given this one? Integral 3x e to the power of 2x. What is going to be the value of the integral of it? You could feel free to try that by yourself if you feel you can. Now, the first thing we need to do is, first off, we know that we need to have a u dv, and that is going to be equal to uv. And that will be minus v du. So this is the basic formula of integration by parts. So what is going to be ru and dv? So in this case, I could basically just make u to be 3x. And so that will come off very easy. So that is du dx. And so that is going to be 3. And if I multiplied the right hand side with dx on the left, we're just going to have du on the left. And on the right, we're going to have 3 dx. Then we need to take e raised to the power of 2x as dv. Now, e raised to the power of 2x will be combined with dx. So that is going to be dv, and that is equal to e raised to the 2x dx. Now, we need to integrate this. So that will be integral dv, and that is equal to integral e to the 2x of dx. So basically what we have here is v, and on this side we have a e to the 2x divided by 2, because obviously if you wanted to integrate e to the 2x, that is going to be e to the 2x, and that should be divided by the derivative of the function, which is the power of e, provided the function is a linear function. In this case, we find that 2x is obviously linear, so that will work. So these are the terms that we have, and we're going to use them to plug into this formula. So be at the back, integral u dv is the same thing as this whole expression. So what we basically are interested in now is everything to the right of that formula. So u is 3x. We're going to write that there. So this is multiplied by v. In this case, v is e to the 2x divided by 2. Then we have minus integral v. V is e to the 2x divided by 2. And du, we have du to be 3 dx. So that is going to be 3 dx. So this could be rewritten as a 3 over 2 x e to the 2x. And on this side, we could have 3 over 2 taken out. And that should be 3 over 2. And this is going to be integral e to the 2x dx. So that is what we have there. Now finally, we need to find the integral of e to the 2x. Basically, that is still going to be e to the 2x divided by 2. Same thing as we had here. So that should now give us 3 over 2 x e to the 2x minus, we got 3 over 2. And over here, we should have e to the 2x. So I need to write 2x there. This is divided by 2 plus c. So I think I will just clear this out. So the final stuff, the final answer we should have here is 3 over 2 multiplied by x multiplied by e raised to the power of 2x minus, now we have 3 over 2 multiplied by 1 over 2 or 2. That means 2 will get multiplied by another 2. So that should give us a 4. And then we have e to the 2x plus c. So that is basically the answer to that question. This is what we have. That is going to be the integral of this expression. Now try this one by yourself. So if you had this expression, what is going to be the integral of this expression? How are you going to solve it? Feel free to pause the video and try doing that by yourself as much as possible. So as we did earlier, we have a integral u dv that is equal to uv minus integral v du. So we need to choose what u will be and what is going to be v. No, not v in this case, but dv. So I should rather use this part. So that is going to be u and dv. So let us say that u is equal to x squared. Now, because we have the value of the power of the first variable to be 2, there is actually going to be a double integration by parts going on for this particular question. So let us solve it. We are basically going to have du to be 2x dx. So by now you should be familiar with how dx came to this other side. Now having got that, this whole part is now going to form dv. So dv is equal to cosine 3x dx. And of course, I need to integrate each part. So that basically reduces that dv to v. Now on this side, we're going to have the integral of it. And so that should be sine 3x divided by 3. So we need to take all this and plug them into this formula. So let us try doing that. Now we have u, which is x squared. That will be multiplied by v. So v in this case is sine 3x over 3. Now we have minus integral v once more, which is sine 3x over 3. Now we have du. So du, that is 2x dx. Now as you can see, we happen not to be done yet because we have another variable here with another variable in that place. So that makes it to be that we would need to start another integration by parts. So this is actually supposed to be equal to, now we're going to have 1 over 3 x squared sine 3x, and we're going to have 2 over 3 coming out because they basically are coefficients, so they're basically going to come out. So that is going to be this way Now we would have x sine 3x dx. Now, you know this is actually familiar with one of the previous questions that we solved. So we would actually take another route of integration by parts again. So first off, we're going to make u to be x. And so we know that du is going to be 1 dx, basically. Then we have dv to be sine 3x dx. So we know that v should be negative cosine. So that will be negative cosine 3x divided by 3. So we need to take all this and plug it into this. So I'm basically going to wipe this out. So that is going to be 1 over 3 x squared sine 3x minus 2 over 3. And so this is going to be, we need to have a uv, so u is x multiplied by v. Now this is v. So that will be negative cosine 3x over 3. And then this will be integral v du. So we know this is v. So because I do not have space, I'm just going to write that there, then find out space as I wipe out some stuff. So this is integral v du. So let me just clean these out. Yeah. So we have 1 over 3 x squared sine x. Whoa, that should be sine 3x. And this is going to be minus 2 over 3. So we have x multiplied by negative cos 3x over 3. So that is going to be negative x cos 3x over 3. And here we have integral v du, which is the same thing as this, and this is divided by 3. Now du, what is du? So du is 1 dx, so I'm just going to write that there. So that is what you have. So we need to work this. Now, of course, that is actually on a simple side because this is actually already done, so that wouldn't actually take too much time. So let us just work it. Yeah. Now, I'm just going to clear out some stuff from here. Yeah. Okay. I think I would wipe these ones also. Yep. So this is much space. So this gives us 1 over 3 x squared sine 3x minus 2 over 3. This is going to be negative x cos 3x over 3. And here we're going to have negative with another negative, creating a positive. Then this will be integral cos 3x over 3 dx. So if we integrated cos 3x, that basically should give us, what should that give us? That is going to give us sine 3x divided by 3. Now bear in mind, we already have another 3. So that basically will get multiplied with this 3. But we'll make it a little bit more gradual. So let me use another color. So this is going to be negative 1 over 3 x cos 3x. Well, okay, I will rewrite this. And this is going to be plus. So we would have sine 3x over 3. And that should be multiplied with another 3, which is the 3 which was there originally. Then there will be a plus c over here. So this is going to be 1 over 3 x squared sine 3x. Now we're going to take negative 2 over 3 and multiply with this term. So what is that going to give? That basically should give us 2 over 9. And so that is going to be multiplied by x, and you have a cos 3x. Now we have negative 2 over 3 multiplied by positive sine 3x over 9. Basically, this is going to give us 9. So that is going to be 3 multiplied by 9, and that should give us a 27. So that is minus 2 divided by 27. This is multiplied by 3x. Well, sine 3x rather. And this is plus c. So this is the answer to the question. Pretty long, ain't it? Yeah. So now we're going to another one. How about this one? What is going to be the integral of ln x dx? So in this case, we just have one term, which is ln x, and we don't have another term there. So the best thing we need to do, we're going to change this and make it look like this. Now we already know that the formula for integration by parts is integral u dv, and that is equal to uv minus integral v du. So we are going to make 1 to be dv, and we will make ln x to be u. If you wanted to do it the other way, that will basically not work. You could feel free to try doing that by yourself, and you would just find out that you would end up in a deadlock, which doesn't actually take you anywhere. So you basically don't want to go that way. So in order to save time, we're just going to go with the way that works. So in this case, we have a u, first of all, to be ln x. So that makes du to be 1 over x multiplied by dx. And so dv, that basically be 1 dx. So we took 1 with dx and made it to be dv. So we need to integrate both sides, and that is going to give us a v on the left, and on the right we should have x. So I just need to place everything within this formula. So that is going to be ln x multiplied by x. This is minus integral of v. Now v, we know that is x. And du, that is going to be 1 over x multiplied by dx. Now obviously this is going to get cancelled. So that should give us x ln x minus integral 1 dx. Now we already know that the integral of dx, that is basically going to leave us with an x. So this will be the answer to the question. X ln x minus x plus c. So let us try one last question. Now bear in mind, this is just the first part of integration by parts, because there is still some more intricate forms of the question under integration by parts. So feel free to check my channel for more of those videos on integration by parts. So this is the last one. What is the integral of x ln x dx? So we're going to use the same technique as we used in the previous question. So we will make, basically we're going to make u to be ln x. So of course du, that is going to be 1 over x dx. And then we will make dv to be x dx. So this is going to get integrated, and so v will form, and this basically should give us x to the 1 plus 1 divided by 1 plus 1. So that is going to be x squared over 2, basically. Okay, so that is what we have there. Now we know the formula is integral u dv is equal to uv minus integral v du. So we know that u is ln x, so that is going to be ln x. And now v, this is what v is. So that is going to be x squared over 2. And then we have integral v again, which is x squared over 2. That will be multiplied by du. In this case, we have du to be 1 over x dx. So obviously, we have x canceling one of it. So that will leave us with just one x right there. So this is going to be 1 over 2 x squared ln x. This is integral x over 2 dx. That is basically what we have left. Now bear in mind, this could be rewritten this way. I could rewrite it as 1 over 2 x squared ln x minus 1 over 2 integral x dx. Okay. Now, that is because I took 2 out of this part and brought it out to be the coefficient of the integral form. So this is going to be 1 over 2, and you have x squared ln x. And over here, we have 1 over 2. Now, if we wanted to integrate x, we know that x is actually raised to the power of 1. So that should be x raised to the power of 1 plus 1. And that is divided by 1 plus 1. And you would have a plus c right there. So the answer here should be 1 over 2 x squared ln x, and we will have 1 over 2, and this is going to be x squared over 2 plus c. So the final answer that we should have, just going to wipe this stuff up here. So that should be 1 over 2 x squared ln x minus, we have 1 over 2 multiplied by another 1 over 2. So that should give us 1 over 4. That is going to be x squared plus c. So that is the answer to the question. So that brings us to the end of this part. Before we go, I just have some test questions for you. Now, try doing these ones by yourself. Find out what is going to be the integral of 2x over 3 ln x plus pi dx. And try this also. Okay, yeah. So try out integral negative 4. Okay, so that is 4 theta. And you have a cosine pi theta d theta. Try solving these ones by yourself.